In the previous lessons, you learned about the different types of particle radiation, the properties of each type, how far each goes in air, how you shield against each type, and the type of hazard it is to the human body. But radioactive decay doesn't just release particles. Sometimes when radioactive decay happens, another type of radioactivity occurs, the last type of radioactive ionizing radiation, gamma radiation. In this lesson, we're going to look at why gamma radiation is different from the types of particle radiation, but also we're going to explore how it's the same, how it has certain properties that define it, how it penetrates matter a certain amount, how we can shield against it, and whether it's an internal or external factor. We're also going to look at the mechanism behind how gamma radiation causes ionization. Let's get started learning about gamma radiation. And just like with the other types of particle radiation, we're going to start by thinking about what gamma radiation is. Unlike alpha particles, beta particles, or neutrons, gamma radiation is not made up of particles at all. It has absolutely no mass, it has no charge, but it has a lot of intense electromagnetic energy. That's right, gamma radiation is made up of pure energy, and it's still ionizing radiation. Now remember, with neutrons are able to penetrate matter very deeply because they don't have an electric charge to cause them to interact with particles and slow them down. Well, since gamma radiation is just pure energy also, it's not going to have an electrical interaction because it doesn't have a charge, so it is going to move a very, very far distance. In fact, gamma radiation can move several hundred to several thousand feet through the air. In this way, it's pretty similar to neutron radiation. However, you may remember with neutron radiation that there is such a thing as slow-moving neutrons and fast-moving neutrons. With all gamma radiation, all of it moves at the speed of light, and therefore you don't need a multi-layered shield like you did with neutron radiation. You just need thick, dense materials like steel, concrete, and lead to protect yourself against gamma radiation. Nuclear power plants release a lot of gamma radiation as they break down the nuclear fuel to make heat and electricity. Nuclear power plants also have a containment room that is thick concrete and steel so as to block any of the radioactivity from escaping. And then finally, gamma radiation is an external hazard to the body because it can completely penetrate the body and harm it from the outside. You don't need to ingest it or absorb it into your body first. It will harm you from the outside even if you're 100 feet away from the radiation source. So gamma radiation is a very, very dangerous type of radioactivity. It's just not made out of particles like the other types of radioactivity were. Let's take a look at the mechanism that makes gamma radiation ionizing radiation. And here once again are our three bonded together carbon atoms that would, for example, make up a piece of your DNA. Here is gamma radiation. Gamma radiation has an immense amount of energy, and if the gamma radiation gets absorbed by an atom, that energy is going to be added to the atom and cause that atom to ionize. So we're going to add this gamma energy to the bottom atom. And notice what happens. It energizes one of the electrons. That's what happens. Gamma radiation adds energy to the electrons on the outside of the atom. Now, because this electron has so much energy, it has just gained enough to completely escape the atom and become a free electron. But because that electron is gone now, where it was holding two atoms together, that bond that was holding those two atoms together is now broken. And this DNA that had these carbon bonds in it isn't going to function the same way anymore. It is broken. That's how gamma radiation ionizes matter, and that's what makes it dangerous. So, like the other types of radiation, gamma radiation can be dangerous because it travels outward from a single source and can travel very, very long distances before it's stopped and can only be shielded by very, very thick and dense materials. Unlike the other types of radioactivity, however, gamma radiation is not made of a particle. Instead, it's made out of pure energy, which has no mass, takes up no space, but can really deliver a punch when it is absorbed by an atom.